Hey, hello everyone. Welcome from Rushi Technologies. In today's session, I will discuss about what is GitHub Actions and why we can go with the GitHub Actions and what are the advantages of using GitHub Actions and where exactly we will use GitHub Actions and what are the advantages of using GitHub Actions over other CI/CD tools. Just we will go through the introduction of GitHub Actions and the use cases of GitHub Actions, the advantages as well as the drawbacks with the GitHub Actions also we'll try to understand. This is just an introduction session, right, about GitHub Actions. So before I walk you through about this GitHub Actions, what is this GitHub Actions, where exactly we are going to use this GitHub Actions, I would just give you an update about a new upcoming DevOps with the AWS Cloud Batch. I'm going to start a new DevOps with the AWS Cloud Batch from March first week. So we will have a demo of a new DevOps with the AWS batch on March 7th. March 7th, that is Saturday. March 7th, 2026, that is Saturday evening 7:30 p.m. We will have a demo and the regular classes will start from March 9th, that is Monday. So the class timings will be evening 7:30 to 9:15 p.m. IST. So, as part of the DevOps with AWS program, we are going to discuss about so many various tools, so many various technologies that is required to become a DevOps engineer or a cloud engineer or SRE engineer. Right? So, as part of this DevOps with AWS curriculum, what we are going to discuss, if you wanted to know the detailed syllabus, you can go to our website. This is our website, rushitechnologies.com. In that website, if you scroll down here, you may see one link, right, get syllabus. If you click on this, right, a detailed syllabus browser will be opened. Here I will be the lead instructor and trainer for this the DevOps with AWS batch in Rushi Technologies, and I am the founder and the trainer of this Rushi Technologies. So I will be teaching end to end from starting to the end of this course. I will be the only instructor. No other instructor will be here, right? So as part of this curriculum, we will discuss about so many things. So first, let me introduce about Rushi Technologies. Rushi Technologies is a premier training center in IT. We are going to offer various teachings like DevOps with AWS and Terraform with multi-cloud and Azure admin with Azure DevOps also. And as part of this upcoming DevOps with AWS program, we will be discussing so many tools, so many technologies. Most of you guys already know about me, myself, Balaji Reddy Lachanagari. I am a founder and trainer in Rushi Technologies, and I have overall total 15 plus years of experience in IT. I already trained more than 10,000 plus ITs to professionals and students in my last 8 years of training journey. Right. So here, as part of this DevOps with AWS curriculum, right, we have so many features, so many tools, right? So here at high level, we will be discussing about, let me tell you, we will be discussing about what is DevOps, what is, why do we need DevOps and SDLC, right? What is a waterfall model, what is agile model as part of the demonstration. And also we'll try to discuss about the Linux and shell scripting. The Linux and shell scripting is the prerequisite to become a DevOps engineer or a cloud engineer or SRE, whatever it can be. So this Linux and shell scripting also we will be discussing in a detailed way, right? So you can, even though you have zero knowledge in Linux and shell scripting, You will become hero in this Linux and shell scripting if you attend our training. This Linux and shell scripting itself, I will teach around 20 sessions, right? More advanced level Linux and shell scripting concepts also will be covered. After this Linux and shell scripting, we are going to discuss about version control or source code management, GitHub. So this GitHub also, as a DevOps engineer, what we are going to do, how to create and manage Git repositories, what branching strategies you can suggest, and how to create a branches, how to merge the changes from one branch to another branch, and also we will discuss about so many advanced GitHub concepts. After that, we will discuss about various build tools for building an application and deploying an application. We are going to discuss about various build tools like Maven, npm, pip, like that. And also we'll discuss about web servers for deploying a static web applications, and also application servers like Tomcat. And we will see how to deploy static websites, how to deploy dynamic web applications again. And also we'll discuss about the reverse proxy and load balancing, using how you can set up a reverse proxy or a load balancing, self-managed load balancers. And again, as part of the cloud, we will discuss about fully managed load balancers. And also we'll discuss about Sonar Cube, a static code analysis tool, DevSecOps, as part of security, right? We are going to discuss about what is the importance of code quality, code coverage, how to check the quality of the code using tools like Sonar Cube, right? And again, after that, we'll try to understand about artifactory tools, build artifactories, right? Like Nexus, what is the use of this artifactory, right? How we can configure and use all these things, right? And first, we'll try to build and deploy manually by learning all these tools. Once you are comfortable with all these tools, later we'll try to bring a CI/CD, continuous integration and continuous deployment concepts, using tools like Jenkins. What is Jenkins? How to use Jenkins? What is continuous integration, continuous delivery versus deployment, and how to set up a CI/CD pipelines using Jenkins, Jenkins master slave architecture, and scripted pipelines, declarative pipelines, multi-branch pipelines, and freestyle projects, shared libraries, like various concepts we'll discuss in a detailed way in this Jenkins. And along with Jenkins, nowadays some people might be using GitHub Actions. So as part of today's session, I am just giving a walk you through about GitHub Actions also. But GitHub Actions also we will be discussing as part of our course in a detailed way also, so that at least you will have a two different tools in the same category. Either you can implement a CI/CD using Jenkins, or maybe you can implement a CI/CD using GitHub Actions also. So GitHub Actions also will discuss here, no, as part of this course, right? So here we will be discussing about configuration management tools, like what is configuration management tools. With the configuration management, what is Ansible, how we can use Ansible for doing configurations. Later later we'll try to understand about the cloud computing. What is cloud, what is cloud computing, what is cloud services, cloud service models. With respect to cloud computing, we will discuss about aws services. As part of this course, we will be discussing about so many AWS services that as a DevOps engineer, we need to be aware, like EC2, EBS, EFS, S3, VPC, networking, load balancing, ELB, Route 53, DNS related, certificate management, auto scaling groups, RDS, relational database, CloudWatch, monitoring, right? Lambda, Lambda, right? What is Lambda? How do we use Lambda? IAM, AWS CLI, and also ECR and EKS, all those services which is required to be known as a DevOps engineer, right? We will be discussing here. Later, we'll try to understand about containerized deployment. Instead of building and deploying our applications in a virtual machines directly, there is something called containerization, containerized deployment. So we'll discuss about what is containerization, why do we need containerization, difference between virtual machines, containers, and also we'll discuss about how to set up a Docker, how to build and deploy applications as a containers, what is Docker registries, and also we'll try to build and deploy various applications developed in various programmatic languages also using Docker, like using Java application, Python application, and even databases also we can run as a containers. We will understand. and we will understand about Docker networking, Docker volumes concept here. And also we will be discussing about container orchestration tools, like Kubernetes, and Docker Swarm also we will be covering, with the Docker Compose also we will discuss. And again, how we can build and deploy applications as a containers in Docker Swarm via Jenkins pipelines also we'll see. And also we'll see how to build and deploy applications to the Kubernetes. This Docker and Kubernetes itself will take more than 2.5 months of extensive training. So you can become a SME in this Docker and Kubernetes with this training. You can easily crack Kubernetes certifications also. If you wanted to go for a certification, you can go and attempt CKA, CKAD also with this extensive training. Apart from this Docker and Kubernetes, we will be discussing a lot of advanced tools in Kubernetes again, like service mesh tools like Istio, ingress controllers and ingress rules, and again package manager for Istio like Helm, and continuous monitoring and alerting using Prometheus and Grafana, and log aggregation and log monitoring using Elasticsearch, right? And also how we can deploy applications to the Kubernetes using GitOps model, using Argo CD also we'll discuss. And along with this, we will have a dedicated resume preparation sessions where we will be discussing about how to prepare your resume, how to showcase your experience as a DevOps engineer with this training. And I can challenge whoever attend this training with the complete efforts and dedication, right? So if you attend this training, if you practice all these things, I can challenge you can easily compete with a person who is already into a DevOps for last 5 years. The person who has a 5 years of real exposure in DevOps, how much knowledge they will have, that much in-depth knowledge also you will get. But only thing, you need to have a proper mindset, you need to have a dedication, you need to have a patience in attending the classes, going through the recordings and practicing things. That hard work, if you do, easily you can compete with the person who already has a 5 years experience in DevOps, right? That much in depth this training will be there. And we will have a dedicated group where you can post your questions, post your queries. And as part of the regular sessions itself, at the end of each session also you can ask if any specific doubts, any specific queries we have also. And we have a dedicated group where I can assist you if you stuck anywhere. The total duration of this training will be 6 months. You might be thinking, sir, why 6 months? But so many people can complete this DevOps training. I know my friends has attended this DevOps training in some other institutes. There they are completing within 3.5 months. Yes, I can also agree, I can also complete the training within 3 months, but we can't cover this much in-depth and extensive training. Even we can also finish the DevOps training within 4 months, but I can tell you just what is what. I can just say what is Docker, what is container, what is image. I will just take one example. You execute this command, you build image. You execute this command, it will create a container, like that. But you don't understand the process, the logic or a process behind these tools, these technologies. Now if you join any applications or a project without having a in detailed exposure and knowledge on these tools, it is very difficult to survive, and it is very difficult to clear the interviews nowadays. So don't worry about the timing. So instead of completing the DevOps training for 3 months and you are struggling to crack the interviews for 1 or 2 years next, you try to spend some time on the training itself. You will get a detailed exposure to these technologies and these tools. Maybe rather than completing the training in 3 months and wasting 1 or 2 years for cracking the job, spend some time in the training with the detailed exposure, right? Around 6.5 months of extensive training. Later, after training, another 2 3 months, you can just prepare yourself and you can easily able to crack the job. So don't worry about the timings and batch timings. Trust me, it's a worth of attending this course for 6 months. That much extensively we will cover. We will make you this DevOps and cloud in these tools. We will make you from zero to hero. As I said, this curriculum is designed as per the market, expectation, as per the expectation nowadays. So this syllabus and curriculum is prepared. So here, as I said, the next batch will be started from March 7th. We have a demo, and March 9th the classes will start. The demo timings will be 7:30 p.m. IST, and class timings also from March 9th. It's a evening batch, evening 7:30 to 9:15 p.m. IST. The classes will be there Monday to Saturday. Initially first 1 month we will have only Monday to Friday, but after 1 month we'll have a sessions on Monday to Saturday. If required, once we start the DevOps tools after completing Linux and shell scripting, maybe some weekends I will have a dedicated Q&A sessions also, where we will be only discussing about questions and answers, and I will clarify your doubts if you have any. Right? And we will record each and every session, and we will give a recording access to all these sessions for 1.5 year, 1.5 years. The training will be for 6 months. Even after training completed also, another 1 year you will have access to these recordings for revision, practice, preparation, like that. So this is the update about the upcoming DevOps with AWS batch. And we have a dedicated YouTube channel. Maybe you can go to our website, and here you can see there is a links also to the GitHub of Rushi Technologies, and YouTube link also. Right, this is our YouTube channel, Rushi Technologies. Right, maybe if you go to YouTube also, you can search with Rushi space technologies. This is the YouTube channel. Right, so here Rushi Technologies you can search. This is our YouTube channel. Right, with this right, you can subscribe this channel, where you will get more updates also. And already we have a lot of sessions, some important concepts I have uploaded into this YouTube channel. You can go through, so that you can understand how the training will be from my side in this Rushi Technologies. Okay, so this is our contact numbers. If you wanted to reach out to me for any specific doubts, you can contact on this number. This is my personal number, and this is the institute number. Right, you can reach out to me on my personal number, or maybe this institute number also. Let's get into today's agenda now. Let's understand what is GitHub Actions already. What exactly this GitHub Actions, why we are going to use this GitHub Actions, what problems this GitHub Actions is trying to solve today. Suppose if you take any application, suppose if you take any application, suppose if you take any application, right? So here, as part of your application development, right, so we need to deliver or release that applications very frequently. So the modern software teams are expected to release the features, that applications, very frequently. And also we need to maintain the quality in our code, quality in our software. And also we need to support multiple technologies. And again, instead of manually building and deploying and releasing our applications to the market, if you are manually doing, there are so many challenges. So if you are manually building and applying, it takes lot of time, and also error prone. Right, so here, in order to release our features, release our applications, or release our softwares very frequently with high quality and security, right, we can use a concept called CI/CD, right, continuous integration and continuous deployment tools, or continuous delivery tools we call it. But here, the core problems, first let's understand the core problems faced by the development team. Right, so every day there are developers developing the applications. Let me tell you, maybe imagine, let me explain with the diagrammatic approach. Imagine you have a developers developing one application. This is application team. This is a application team developing some software, and as part of that, right, they will try to develop the code locally, and they will try to commit and maintain the code in SCM, source code management tools. So source code management tools like GitHub, and maybe you can use any other hosting platforms like Bitbucket or AWS code commit or Azure repos, like that. Here we will have a source code. Every day, so many times there will be a pushes to this source code repository. Our application team push code multiple times in a day without proper automation. If there is no automation for taking the latest code, compiling the code, checking the code quality, code coverage, and creating an application package, deploying the application package, if there is no proper automation, if you are manually doing, right, there are so many problems. So as I said, we need to release our applications very faster, reliable, right? So every day multiple times the changes will happen to the source code. Without proper automation, this will lead to a manual deployment. You need to manually take the latest code, compile the code, run the unit test cases, check the code quality, create an application package, and deploy. That manual deployment steps. And again, inconsistency. Manual means inconsistency. Inconsistency means error prone, human errors, error prone. Suppose as a human, you may miss some step or you may miss something to build and deploy. It will cause inconsistencies and delayed releases. But here the application team need a full automation, fully automated CI/CD pipelines that will run on every code change. Suppose you already know CI/CD, continuous integration, continuous deployment. That is one type of process, strategy, or a culture in DevOps, where whenever there is a change in the source code, instead of you manually take the code, compile the code, run the unit test cases, check the code quality, code coverage, and create an application package. Maybe if you are using Docker, create a Docker image and push the image to the registry. That is continuous integration. And the deployment means taking that package and delivering to the lower environments like dev QA, or maybe delivering to the production environment also with that deployments, right? But here if you are manually doing, so many problems will come. But we need to automate using CI/CD. You can create a CI/CD pipelines using CI/CD tools, so that we can automate. But here we have so many CI/CD tools. We have so many CI/CD tools, like so many CI/CD tools. Like suppose if you guys are already familiar, there is a CI/CD tool like Jenkins. There is a CI/CD tool like Jenkins. Also, you can use, or maybe you can use Bamboo. You can use tools like Bamboo or Travis CI, Travis CI, Circle CI. Like that, you have so many CI/CD tools, right? So you can use tools like Jenkins. But here, the problem with this is there is a poor integration between SCM repository like a GitHub and CI/CD. So suppose you are using CI/CD tools. You are using a CI/CD tools like Jenkins or maybe Bamboo or maybe something else. But here there is a poor integration between the CI/CD tools with source code management. Although GitHub is the most widely used CI, source code platform where we are going to maintain the source code, but the traditional CI/CD tools, like Jenkins or any other tools require separate servers. So in order to implement a CI/CD pipeline using tools like Jenkins or any other CI/CD platforms, so first you need to create a servers. You need to create a servers, that Jenkins servers like a Jenkins master, Jenkins controller, or a Jenkins slaves like that also. You need to create an infrastructure and you need to set up a Jenkins. I'm just giving example like traditional CI/CD tools like Jenkins, Bamboo, all those things. Suppose here you are trying to set up a Jenkins and you are trying to configure this as a Jenkins master controller. In the Jenkins sessions, we discussed about Jenkins master slave architecture. What is master? What is slaves or agents? Maybe this is Jenkins controller. Maybe you can, if required, you can distribute your jobs to the slaves, Jenkins slaves. Right? We discussed about all these things in our regular trainings. Right? So this is Jenkins controller, this is Jenkins slaves or agents. And you need to set up all these things. You need to maintain, manage all these servers also in traditional CI/CD tools. So although GitHub is widely used source code platform, a traditional CI/CD tools requires a separate CI/CD servers. And again, manual webhook configuration. Suppose using Jenkins, here you have created a Jenkins pipeline, that Jenkins job or a Jenkins pipeline. So this pipeline has to be triggered whenever there is a change in the code. Here again, what you need to do, you need to create a webhook in GitHub, right? In GitHub repositories, you have to create a webhook. You have a different triggers in Jenkins. We discussed like build periodically, poll SCM. Similarly, there is something called webhook. So maybe you have to create a webhook also, so that that webhook will inform that there is a change in the source code, like that, so that the pipeline created for that webhook is going to be triggered. That pipeline will have the commands or a stages or a steps which will take the code, compile the code, run the unit test cases, check the code quality, code coverage. If everything looks good, push that package to some artifactory, later deploy that into dev or QA servers or production servers according to your requirement. You have a pipelines. But here, even though GitHub is most widely used source code platform, but traditional CI/CD tools requires separate servers. You need to create and manage and set up, and you need to create a webhook configurations. And also in CI/CD tools like Jenkins or maybe tools like Bamboo, you need to create a tokens, secrets, credentials, and permissions, networking. All these things you have to take care. But if you go with this traditional CI/CD tools, the complexity is increased. Why the complexity is increased here for a DevOps engineers? The DevOps engineers is responsible for creating an infrastructure and configuring a CI/CD tools like Jenkins slaves, and you need to configure a webhooks, and you need to maintain secrets, all those things. So complexity is going to be increased, security risk and operational overhead, this approach. And also infrastructure management. As I already said, in order to set up a CI/CD tools, first you need an infrastructure. Traditional CI/CD tools requires the team. The traditional CI/CD tools requires teams to manage. Teams means that DevOps team or infrastructure teams to maintain a separate servers where you can run your Jenkins or Bamboo, and again that agents also you can run. And you need to install plugins. You need to install plugins, and you need to take care about scalability, availability, OS, and security patches like that. So here, right, you need to create a servers where you can set up your CI tools and agents, and you need to take care about installing a plugins, Jenkins plugins or any other CI/CD you are using, that plugins, that plugin upgrades, and scaling the servers, scaling the capacity of the server, scaling the storage of the CI servers, CD servers, right? OS patches, security. This DevOps team spend more time. This DevOps teams spend more time on maintaining the tools rather than delivering the software. Suppose instead of spending the time on creating a pipelines, you are going to spend more time on creating the servers and configuring the servers with required CI/CD tools here, that CI/CD softwares, that agents, plugins, all those things. The DevOps teams will spend more time on maintaining the tools rather than delivering a software here. And here again, we need to have a event driven automation. We need to have an event driven automation. The developers want the pipelines, that pipelines to be automatically run whenever there is a changes in your source code, or maybe when the pull request is created, or when the merges has happened, when the tags or releases is created, or maybe you wanted to periodically run your pipelines. So you wanted to automate, but here you have some options, like you can create a webhooks, or you can create build triggers. The build triggers using webhooks are build periodically, like that. But you wanted this type of things also to be taken care. And again, support for polyglot applications. Suppose nowadays, if you take any application or any project or any softwares, there are so many applications are following a microservices architecture. In that microservices architecture can be followed polyglot, means each microservice can be developed in different programmatic language like Java, Python, Node.js, and maybe that applications are built and deployed into Docker or Kubernetes. And again, we may need to create an infrastructure and configurations using Terraform. But if you are using tools like traditional CI/CD tools like Jenkins, in the Jenkins you need to configure all these softwares. Maybe for building Java based application, you need to have a Java or Maven should be configured in the global tools configuration. Or maybe you wanted to work with the Docker, you need to install Docker and create a Docker images via your Jenkins CI/CD servers. Like this, again, more time you will spend on maintaining and managing the servers with required plugins, required softwares for CI/CD also. But the requirement is CI/CD pipelines must be flexible and language agnostic, right? And also it should support any programmatic language, and it should support containerized deployment, virtualized deployments, like that also. But you wanted to focus more on developing the pipelines rather than configuring and maintaining your CI server, CI agents, plugins, OS patches, scalability of CI servers, like that. So here, the problems with the traditional CI/CD tools, the limitations of a traditional CI/CD tools, the tools like Jenkins, Bamboo, TeamCity, these type of things has several challenges. The traditional CI/CD tools has several challenges. What are those challenges? Heavy infrastructure, heavy infrastructure dependency. You need to have a dedicated servers or a VMs where you can set up your Jenkins controllers, and separate CI servers where you can set up your Jenkins slaves, like that. Heavy infrastructure dependency requires a dedicated servers or a VMs and a manual agent scaling and higher operational cost also here. And plugins and dependency, large number of plugins is available, and the plugins may be incompatible after some upgrades. Maybe Jenkins has so many plugins, Bamboo has so many plugins, you are going to use that plugins to automate something in your pipeline. Maybe the plugins are maintained by some open source people, maybe some plugins may become incompatible after some upgrades in the Jenkins versions, and frequent plugin breakages will be there, difficult to troubleshoot all those things. Plugin and dependency issues and scaling. Suppose so many people are using your CI/CD tool like Jenkins, so many jobs are getting triggered at the same time. In Jenkins, if you don't have enough enough resources with enough CPU, enough workers, your jobs will go into a queue. Your job will go into a queue, build queues during the peak usage. And again, manually, you need to create a agents, that CI/CD agents, and connect the agents, slow feedback to developers, like that. And again, here, complex setup and maintenance. Setting up a traditional CI/CD tools, setting up a traditional CI/CD tools like Jenkins, TeamCity, Bamboo, these type of things involves so many things. So first you need to have a servers. That servers can be in on-prem or a cloud. You need to have a servers where you can set up tools like Jenkins or TeamCity or Bamboo. Then you need to install the required plugins in that CI/CD servers, and you need to manage the credentials, and you need to create a pipelines, and again you need to create a agents and maintain that agents, right? And also you need to create that infrastructure, basically create a infrastructure like a servers, and install that CI/CD softwares, and install the plugins. And for this, maybe you need to maintain the agents also, your CI/CD agents also. After that, you can create a pipelines. Here, DevOps team will spend more time. Initial setup will take hours, even days also, in the beginning. And again, we may have a lot of security challenges also, manual SSH and token management, securing CI servers, complex access control, like that. We have so many challenges with the traditional CI/CD tools. Now there is something called GitHub Actions was introduced. This GitHub Actions is also introduced by GitHub as a company. So this GitHub Actions is introduced to solve some challenges with this traditional CI/CD tools. Whatever challenges we have with the traditional CI/CD tool, in the traditional CI/CD tool, you are responsible as a DevOps team, you are responsible for creating the servers with required storage, and again these servers to be part of some network, and you need to create that required servers, required storages, networks, firewalls, and you need to create a servers and join that servers as an agents to the Jenkins or any other CI/CD. So securing and maintaining the infrastructure and configuring that plugins, everything you need to take care, right? But if I use tools like GitHub Actions, they are going to eliminate so many challenges. This GitHub Actions, if you are using this, GitHub Actions was introduced This GitHub Actions was introduced to eliminate these challenges by providing GitHub native cloud managed CI/CD solution. Suppose if I am using GitHub Actions, this is a GitHub native cloud managed, which means you no need to provision any server to run the pipelines. You no need to provision. You no need to create any servers to run the pipelines. You no need to create any servers. You no need to set up any CI/CD tool if you are using GitHub Actions, and you no need to worry about scalability. You no need to worry about plugins, agents, right? So who will take care? That GitHub cloud, that GitHub itself will take care. So GitHub Actions is created to eliminate these challenges by providing a GitHub native cloud managed CI/CD solution that will directly work inside your Git repositories. You no need to have a separate CI/CD setup. You no need to have a separate CI/CD setup. If you are using GitHub as a source code management, in GitHub you are creating a repositories where you are maintaining a source code. You typically don't need a separate CI/CD setup, because this GitHub Actions is going to work within GitHub directly, right? So this GitHub Actions was eliminated. GitHub Actions was created to eliminate these challenges by providing a GitHub native cloud managed CI/CD solution that will work directly inside your Git repositories. So how this GitHub Actions is solving these challenges? How GitHub Actions is solving these challenges to set up a traditional CI/CD? Suppose traditional CI/CD tools like Jenkins, Bamboo, these type of things, you need to create a servers, you need to install that softwares, install the plugins, right? Then only you can create a pipeline. But if I am using a GitHub Actions was eliminating all these challenges by providing a GitHub native cloud managed CI/CD solution that works directly inside your Git repositories. So here, serverless CI/CD. This GitHub Actions is like a serverless CI/CD. Serverless CI/CD. What do you mean by serverless? You no need to create any servers to run your pipelines, your jobs, your CI/CD jobs. Zero infrastructure management. But you might be thinking, without servers, how I can run the pipelines, how I can run the jobs? This GitHub Actions is like a fully managed. This GitHub Actions is like a fully managed CI/CD platform. CI/CD platform. This GitHub Actions is like a fully managed CI/CD platform from GitHub, right? So they will take care about the underlying infrastructure. So you can just create a pipelines using GitHub Actions, and GitHub will execute that pipelines, but you no need to create any infrastructure to set up CI servers and CI agents like that. So it's a serverless CI/CD. GitHub Actions is going to solve these problems. One feature, one advantage is serverless CI/CD, zero infrastructure management. So no CI servers or agents to set up and manage. You no need to create any servers. You no need to worry about agents. You no need to set up and maintain. Who will take care? GitHub will take care as a GitHub as a company. And we no need to worry about OS patching, scaling, that high availability setup for infrastructure. I mean, say for CI/CD. So you no need to create a servers, and you no need to worry about configuring the CI/CD tools. Basically, you no need to do OS patches in your CI servers like that. You no need to worry about scaling the CI agents, high availability setup, and you no need to worry about agents. No agents to scale manually. Everything this GitHub will take care. So infrastructure required to run CI/CD, not for your not your application infrastructure. Your applications will be, again, you will deploy in your on-prem data center, or maybe you will have a cloud like AWS where you will have a infrastructure where you will deploy application. But here I am talking about CI/CD infrastructure. You need an infrastructure to set up a CI/CD, right? That servers where you can install CI software, agents. So that infrastructure required to run the CI/CD will be taken care by GitHub if you are using GitHub Actions. So infrastructure, not your application infrastructure. I am talking about infrastructure that is required to set up a CI/CD tools. That CI/CD tools infrastructure will be taken care by GitHub directly. So you no need to create a servers or agents to set up and manage. Infrastructure is fully managed by GitHub, so it will reduce the DevOps operational overhead. You no need to spend more time on creating a servers to set up your CI/CD. You no need to worry about creating an infrastructure and installing that CI/CD tools. You no need to worry about plugins. You no need to worry about agents. You can directly create a pipelines. You can go and directly create a pipelines using GitHub Actions. But the GitHub Actions internally require servers where it can execute your pipeline code, pipeline steps, right? But that infrastructure will be taken care by Git. That is what the meaning of serverless CI/CD, right? No CI servers, no agents to set up and manage, right? No, this infrastructure is fully managed by GitHub, and it is a native GitHub integration. So this Git Actions works directly inside Git repository. So it is even very simple. In a SCM repository, in your SCM repository, you are using GitHub as a SCM repositories to maintain the source code. So this Git Actions works directly inside this Git repositories. No webhooks is required. You no need to create any webhooks. So you are going to create a pipelines using GitHub Actions in your Git repository, so that whenever there is a push, whenever there is a PR, whenever there is a PR, whenever there is a push, whenever there is a merge, that GitHub Actions pipeline will be executed. So you no need to create a separate webhooks or external integration. Pipelines will trigger automatically. GitHub action pipelines. Suppose if you are creating a CI/CD pipelines using GitHub Actions, that pipelines will be triggered automatically in GitHub events, based on the GitHub events, like that. Again, simple pipeline as a code. Again, if you are using GitHub Actions, pipeline code is very simple. Suppose in GitHub Actions, the pipelines you are going to define in a YML format, YAML format. Suppose if you are using Jenkins, in Jenkins you are going to write a pipelines in a Groovy script, Groovy scripting, that declarative or a scripted, you are going to write in a Groovy scripting. But in GitHub Actions, you are going to use a pipelines in a simple YAML file. It is easy to read, easy to understand, easy to write also. And again, this pipeline as a code, this Git Actions pipeline also as a code we will define in a YML file, and that YML file also will maintain in the version control system only. Along with your source code, along with your source code, you will have a CI/CD pipelines code also in the form of YAML. And again, this GitHub Actions also support event driven automation. So that GitHub Actions workflow, that GitHub Actions workflow or a GitHub Actions pipeline, we will discuss about what is workflow, what is a job, what is a step, what is a runners. We have so many concepts: runners, actions, runners, jobs, right? Triggers, like that. There are so many concepts in this GitHub Actions. When we try to write a pipelines using GitHub Actions, so that time you will understand so many things. But now understand this GitHub workflow. That workflow is nothing but your pipeline. That workflow is nothing but your job. This GitHub workflows or jobs will be executed on push or pull request or a tag or a release, like that. And again, that GitHub Actions is integrate, having an integrated security, built-in security, right? If required, in GitHub Actions also we have a encrypted secret storage, and you have a environment protection rules, and also you can give permissions also, who can create a pipelines in GitHub Actions, right? Authentication and authorization, and also least privilege control also, all these things, who can create a pipelines in GitHub Actions, who can run the pipelines also, all those things also there. So here, this is more secure than manually managed CI/CD servers. And again, auto scaling. So GitHub is going to host. GitHub has a hosted runners. Runners means basically a server. GitHub Actions will execute its pipeline. GitHub will execute that pipelines using runners. That runners are nothing but a servers only, but that is not our servers. There is a GitHub hosted servers, GitHub hosted runners. If required, you can also configure self-hosted runner. We will discuss about runners, workflows, jobs, how to create a runner, self-hosted runner also. But GitHub also has a hosted runners. Runners means that is basically a server where your pipeline will be executed. But GitHub hosted runners means GitHub managed servers. So that GitHub hosted runners will be scaled automatically. There is no queue or a agent management, right? You can directly write a pipelines in GitHub Actions, but GitHub Actions pipeline will be internally executed in a runner. That runner is nothing but some server, but that server you no need to create, you no need to maintain. The GitHub will maintain, like that. And again, here in GitHub also there is a so much broad ecosystem and marketplace. So the way in Jenkins you have something called plugins. In GitHub also there is something called actions, reusable actions. So GitHub in GitHub marketplace. In GitHub marketplace we have a thousands of reusable actions. That actions are like a plugins are a shared libraries in Jenkins. Suppose if you are familiar with the Jenkins, right? You have a plugins or a shared libraries. These actions also similar to that. So in order to perform particular task in GitHub pipeline, GitHub Actions pipeline, you need to have some kind of a setup. So you can use this reusable actions. There are thousands of reusable actions. And again, using GitHub Actions also you can easily integrate with the Docker. Using GitHub Actions also you can write a pipeline where you can build a container images, and again you can push that images and deploy that into your actual servers. Your actual servers, so easy integration with the Docker, Kubernetes, Terraform, and any other cloud also. That GitHub Actions supports. That GitHub Actions support various programmatic languages, and various ways to build and deploy. Also, everything there is broad ecosystem and marketplace. So, but these are the advantages of using GitHub Actions, right? You no need to maintain the servers, CI servers, CD servers. You no need to worry about scalability, availability of your CI/CD setup. You no need to create any servers to run your pipeline. GitHub will take care if you are using GitHub Actions, and you no need to maintain and manage any agents. You no need to worry about plugins. You no need to worry about high availability, scalability, all those things. GitHub itself will take care if you are using GitHub Actions. But we have some challenges here, disadvantages or challenges also with the GitHub Actions. So vendor lock into the GitHub. Suppose I wanted to use GitHub Actions as a CI/CD. I wanted to write a CI/CD pipelines using GitHub Action. This works only with the GitHub repository. Suppose your source code is not there in GitHub. Your source code is there in other other SCM platforms. Like maybe you have a source code in Bitbucket, or maybe you have a source code in GitLab. Suppose you have a source code in maybe AWS code commit, like that. So in that scenario, it is not ideal. It is not ideal. Suppose if your source code is there in GitHub repository, then you can go and use GitHub Action. But let's say you started using GitHub Actions, your source code is in GitHub, and you are started using GitHub Action, but for some reason your company, your client, or your project says migrate this source code to different SCM tool. For some reason we don't want to have it in GitHub. Maybe migrate this to some other tools like Bitbucket or that type, different tools. That time, do we need to completely rewrite your CI/CD pipelines again? Maybe using another CI/CD tools, maybe that can be any other CI/CD tool supported by that platform, like that. Yes. So that drawback here is you are going to stick to GitHub only, because this GitHub Actions will work only with Git repositories. So you are going to stick to the GitHub only. You can't migrate your code to other SCM platforms if you wanted to migrate. But if you are migrating, you need to rewrite the CI/CD pipelines in other platform. That can be traditional CI/CD tools you can use, or maybe you can use any other platform specific CI/CD tools also. Right here, we are going to vendor lock into the GitHub, and again limited control on the hosted runners. Hosted runners is nothing but the servers where your pipeline will be executed. But if I am using Jenkins, you are only having a server. You are only creating a server. You are only creating a server. You are only managing the server. You are only installing Jenkins here. So if you are using tools like Jenkins, you have a complete control on the servers. Maybe you can have a server with whatever OS you need, whatever patches you need, whatever you wanted to do, you can do. But here, if you are using GitHub Actions, GitHub has a runners. Runners means the servers, right? Where your pipeline will be executed. But we don't have a limited control, because who is going to maintain that runners? That runners are nothing but a servers that is maintained by GitHub as a company, GitHub as a platform. So they have a runners with some fixed OS images, and maybe we have a limited customization and execution time limits. Execution time limits. Again, this GitHub Actions is not free. This GitHub Actions is not free. So everything is chargeable here. because they are going to have a servers, they are going to maintain and manage the servers, and you are using their platform, you are using their platform to run your jobs, your pipeline, right? So it is not free, you have some limits. Suppose if you are using GitHub for free also, if you are using GitHub for free also, only 2000 minutes, only 2000 CI/CD minutes only free per month, which means you can create a pipelines using GitHub Actions, and within 1 month only 2000 minutes of execution time only it will free. What do you mean by 2000 minutes of execution time? Means suppose you have created one pipeline in GitHub Action, and that pipeline is executed for 10 minutes. So 2000 minus 10, you have only 1990 minutes of execution time. Suppose same pipeline or a different pipeline, again it is executed maybe 20 minutes, again you will have only 1970 minutes of execution free. Suppose you have so many jobs, so many repositories in your GitHub, and so many pipelines, so many times executed, only 2000 execution minutes only free, but after that it is chargeable. But if you are using for enterprise companies, you will run so many pipelines so many times within a month, that free minutes are not going to work. In the long run, you will execute your pipeline so many times, so that time cost also may increase. For each pipeline, how much a time it is executed, they are going to charge, because they are creating a servers internally, they are managing the servers. That is fully managed CI/CD platform, GitHub Actions. GitHub Actions is like a fully managed CI/CD platform, but Jenkins is like a self-managed CI/CD platform. Self-managed means you are creating a server, you are using Jenkins to set up a CI/CD. Jenkins is free. Jenkins is free. There is no charges for Jenkins. But the servers that you are creating, you are maintaining, where you are running Jenkins, that servers is chargeable. But here Jenkins is free. But if you are using tools like GitHub Actions, servers also managed by someone else. And when you are using this GitHub Actions, how much time you are using that GitHub Actions, based on that they will charge. Based on that they will charge. Right? That is what fully managed CI/CD platform. GitHub Actions is like a fully managed CI/CD platform from GitHub. So free time, free minutes are limited. Free minutes are limited. High usage, high cost. Suppose you are using GitHub Actions, for so many applications, so many repositories, so many times, cost also will increase. And again, you need to do cost planning for large applications, right? Whether can I go and use GitHub Actions for long run for very big applications, or maybe can I go and use self-hosted with the free CI/CD softwares? Maybe servers only I will pay, but for a CI/CD you no need to pay like that. You can think and you can decide. But here we have a lot of advantages with a few limitations. Limitations is you need to stick to the GitHub only, and you have a limited control on the hosted runners. Anyhow, that is also fine, because if required you can create a self-hosted runner instead of git hosted runner. You can create a self-hosted runners also. We will see that self-hosted runners, how it works in the future sessions. And also cost also may increase, high usage, high cost. And again, maybe for very advanced automation you wanted to do, advanced approvals, visualization you need, maybe it is limited here, less mature for complex enterprise workflows. So you do, suppose you need to have a very advanced CI/CD pipelines, maybe approvals with a lot of advanced approvals, and also visual pipelines, UI, like where I can see all my jobs. But this GitHub Actions, it is like at a repository level only you can see the how many times it is executed. But if you are using tools like Jenkins, in one place you can see how many jobs you have. But in GitHub Actions, each repository, separate pipeline, separate UI, like that only you may see here. So less mature for complex and enterprise workflows. And here debugging also sometimes it will become harder. Logs only available during workflow execution here. But again, when to use GitHub Actions and when we should not use GitHub Actions also, let me tell you. So you can use GitHub Actions when your code is in GitHub only, you want quick CI/CD setup. Suppose you can use this GitHub Actions when your source code is in GitHub, that GitHub for free, or GitHub Enterprise, or GitHub Enterprise Cloud also fine. When your code is in GitHub, that GitHub for free or GitHub Enterprise, GitHub Enterprise Server or Enterprise Cloud also you can use. And you want quick CI/CD setup, just minutes. You no need to waste much time in creating a servers and configuring CI/CD tools there. You can quickly create a pipeline, and you will prefer low maintenance and serverless CI/CD. CI/CD you wanted to implement without creating and managing the servers to set up the CI/CD. You prefer low maintenance and serverless CI/CD, you can go. And if you are using GitOps, if you follow GitOps workflows, event driven workflows, you can go and use. And maybe again you are working with the cloud native applications like Docker, Kubernetes, Terraform. Also this GitHub Actions is recommended, and it is recommended for small to medium teams, medium projects, medium applications. It is recommended for small teams and startups. You will get fast feedback and develop productivity is high. And typical use cases, you can use this GitHub Actions to create a pipelines for your microservices, cloud deployments, open source projects like that. But it is not recommended to use GitHub Actions. It is not recommended to use GitHub Actions. Avoid or consider using GitHub Actions when you need full control on the CI infrastructure also. You need a full control on the CI infrastructure. CI infrastructure means the servers where you are configuring your CI tools like Jenkins servers like that. And heavy legacy workloads. Don't go with GitHub Actions for old type application. Maybe you require a lot of a complex automation. Maybe GitHub Actions may not support. That time you can go and use the traditional CI/CD tools. Suppose you want a single CI/CD tool across all non-GitHub repos. Suppose you are having a source code not only in GitHub, maybe you have a source code in GitHub, maybe you have a source code in maybe something else like maybe AWS code commit. In this case, if you have a source code in other platforms, you can't use GitHub Actions. Maybe that time you can go and use traditional CI/CD like that. So here, what I wanted to say, the final recommendation here, use GitHub Actions if you want the simplicity, speed, GitHub native CI/CD. So you focus on application, you just leave the CI/CD infrastructure management of CI/CD to the GitHub. But use the Jenkins, you need extreme customization. You need to manage complex enterprise application, and again you need a support of multiple SCM platforms. You have source code in a different SCM platforms. That time also you can go and use traditional CI/CD. So here I am just comparing Git Actions with the traditional CI/CD. Here, suppose if I am using suppose here infrastructure. Suppose if I am using GitHub Actions, who is going to maintain and manage the infrastructure of your CI/CD? Infrastructure of CI/CD, not application infrastructure. Applications will be still deployed even though you are using GitHub Actions. The GitHub Actions will internally use some managed servers to run the pipeline. But even though you are using GitHub Actions, the applications built and deployed, built via GitHub Actions will be deployed to our own infrastructure. That can be in cloud like AWS, or that can be in Azure or GCP or on-prem. But here infrastructure means the CI/CD infrastructure, the infrastructure required to set up a CI/CD. So that will be taken care by GitHub, fully managed. Infrastructure is fully managed in GitHub Action. Suppose if you are using traditional CI/CD tools, the infrastructure required to set up a CI/CD, you need to manage. And the setup time is minutes in the GitHub Actions. Why minutes? You just go and create a pipeline directly in GitHub Action. You no need to create a servers and set up that CI/CD servers. But in case traditional, it will take hours and days also to create a server, set up the CI/CD tools, agents, all those things. And here GitHub integration inbuilt will be there. But in traditional CI/CD tools, external means your source code is in GitHub, Jenkins is separate. You need to take the source code from GitHub to the Jenkins, and you need to create a webhooks like that. That is external integration. This is native integration, inbuilt integration. Scaling automatic. Scaling means your CI/CD scaling. Suppose so many jobs are at a time you wanted to run. You need to scale agents, your CI agents, right? That type of scaling automatic because it is fully managed infrastructure for CI/CD. Here manually you need to take care, and maintenance is minimal because GitHub will take care of infrastructure maintenance, OS upgrades, all those things. But here maintenance is also high. Security built in, Again, you need to implement security in yourself in traditional CI/CD. So developer experience is excellent. Here it is complex. That is what GitHub Actions with the traditional CI/CD. So GitHub Actions simplify. In one word, if I have to say, GitHub Actions is going to simplify CI/CD, and it is going to reduce operational burden, and it is going to enable fast and secure event-driven CI/CD from GitHub repository. So this GitHub Actions will allow the teams to focus on building and deploying the software, not managing CI/CD infrastructure. This GitHub Actions will allow you to focus on building and deploying applications, that pipelines you can focus rather than managing the CI/CD infrastructure. That is GitHub Actions. Now this is just a problem statement, right? Background, why CI/CD? Again, what is the challenges with the traditional CI/CD? What is GitHub Actions, like that? So with this background, let me give you introduction about exact GitHub Actions. What is GitHub Actions now? So here, so GitHub Actions, let me tell you. So what exactly this GitHub Actions? So this GitHub Actions, as I already said, let me tell you what exactly this GitHub Actions all about. So this GitHub Actions, so GitHub Actions is a CI/CD platform. GitHub Actions is a CI/CD platform built in directly inside GitHub. GitHub Actions is a CI/CD automation platform built in directly inside GitHub. It will let you to run workflows. Workflows means jobs. So it will let you to run workflows or jobs. It will help you to automate a task. This GitHub Actions will help you to run workflows or jobs. It will let you to run workflows or jobs. It will help you to automate a task like building the code, executing the unit test cases, and deploying applications, creating a Docker images, pushing the artifacts, like that. But here, same thing we have already done using Jenkins, right? Using Jenkins also, you have taken the latest code, compile the code, run the unit test cases, check the code quality, code coverage. Also we can build and deploy like that. But this GitHub Actions also trying to do the same, right? You can implement the automation workflow using GitHub Actions. But it is a GitHub Actions is a CI/CD automation platform built in directly inside the GitHub. So GitHub Actions is like an automation engine. It is like an automation engine inside GitHub, where every automation is written in a YML format and executed automatically using runners. Runners means servers, but that you no need to create. GitHub only will internally have a runners. On that runners, it will run your jobs, your pipelines. So you don't need anything. You don't need anything for automation. You don't need any servers. You don't need any plugins. You don't need any master, like no Jenkins master, no external CI tools. So everything internally GitHub will take care. So what problem this GitHub Actions are trying to solve? In real projects, you wanted to repeatedly do this. In real projects, you wanted to repeatedly build the code using some build tools and run the unit test cases, check the code quality, code coverage using Sonar Cube. And maybe you wanted to build a Docker images, scan the Docker images, and you wanted to deploy that into some Kubernetes cluster or some VM or maybe some container, and you wanted to send a notifications like that. Here, you wanted to do this type of automation, you are going to use CI/CD. So you have last time we used Jenkins. So we created a server. That server can be non-prem or a cloud, that doesn't matter, where you have installed Jenkins and you have created few more servers and joined these servers as a slaves or agents to this Jenkins. In this Jenkins, you created a pipeline. But along with pipeline, you have to create a servers. You have to manage the infrastructure. You need to take care about high availability, scaling, security, patching, all those things, plugins, upgrades, like that. But if I use this GitHub Actions, in order to do these type of repeated tasks, you just need to create a pipeline. You just create a file. The way in the Jenkins, you have a Jenkins file where you are creating a stages, steps, like that. In GitHub Actions, you just create one folder inside your Git repository. In whatever repository you have a source code. In whatever repository you have a source code, inside that you just create one folder called a .github folder. Inside that .github folder, you just create one more folder called workflows folder. You create a one file. with the YAML extension. This is like your pipeline, workflow pipeline. So in this you will define what you wanted to do. In this YML file you can define what you wanted to do, whether you wanted to build the code, whether you wanted to run the test cases, whether you wanted to build a Docker image. In this file you will write, but you are not creating a servers to run this. That will be internally taken care by GitHub. That is what the meaning of fully managed CI/CD platform. So in order to do this type of repeated task, without you need to create a servers, you no need to manage any plugins, you no need to worry about CI setup. You just create a file pipeline in GitHub like this, then GitHub will take care of executing your stages or steps according to this pipeline. Here why GitHub Actions? Again, built directly inside GitHub, no integrations needed. Free minutes for public repository. Free minutes for public repository. Suppose you are using GitHub for free. Suppose this is my GitHub account, my personal GitHub account. Here you can go and see, right? Here you can go and see. Here you can go and see how much free also there. Billing and licensing like that you can see here. Billing and licensing like that you can see here. You can see GitHub Actions also there for how many time, how much free like that also you can see. Here you can see, right, how much is available like that also. Here you can see your usage overview, budget also. Here you can see I am using for free. Here overview, billing and licensing overview, like I am using for free. Suppose you are using GitHub Actions also, these many minutes free like that. So here GitHub Actions also how many minutes free. Here you can see GitHub Actions. Here per month, per month 2000 minutes is free, but I have some pipelines already created using GitHub Actions, so only 2 minutes got executed. This much is free, but after this everything is chargeable again. So that's why it is not completely free, only limited free. And here again you can use some storage to store your artifacts. Here also you can store your artifacts. Here you can maintain your packages the way you are using Nexus or a JFrog, where you are storing your jar where like that. Here you can use this storage also to store some kind of a packages, but for free of cost only 500 GB is free, but after that it is not free, right? So this is free, right? So if required you can go and see it is free only this much, but after that again chargeable, right? You need to upgrade your plan, and you need to pay money to the GitHub company. GitHub is internally, I mean to say, now GitHub is acquired and maintained by Microsoft. So that Microsoft as a company maintaining a GitHub now, so you need to pay if you wanted to use without any limitations this GitHub Actions, that package manage that artifactories in GitHub itself like that. So the way we have a source code management in GitHub, similarly we have a CI/CD platforms artifactory management also in GitHub, but that is not completely free, limited free, right? But some companies may, instead of spending so much time on the configuring CI/CD tools, instead of you create and maintain the servers, you can use GitHub Actions directly. But you need to check price comparison also, whether if I go and use GitHub Actions I need to pay more, or maybe if I am using self-managed or traditional CI/CD I need to pay more. You need to compare and you can decide like that. But some companies will use GitHub Actions because they are going to reduce lot of operational overhead. Operational overhead will be reduced, maybe in charges might be maybe same or different based on other model, right? So here what I am trying to say, built in this GitHub Actions are directly built in inside GitHub, no integrations needed. Free minutes for public repository, fast setup. You just create a YML, you just add a YML. In that YML you will have a pipeline. That YML is a pipeline. And GitHub Actions supports all the languages like Java, Python, Node.js, Golang, and it supports Docker, Kubernetes, and cloud deployments also. Via this GitHub Actions pipeline you can deploy your applications in a VMs, you can deploy your applications in a Docker, you can deploy your applications in a Kubernetes, and that Docker and Kubernetes or VMs can be in on-prem or a cloud also we can deploy. And again here to 20,000 plus actions. These actions are like a plugins in Jenkins. Already these many actions are available in GitHub Marketplace. You can use any of them, right? and multiple platform support like that. And again, GitHub Actions support different runners means machines. You can run your job, you can run your job using GitHub Actions on any runner means machine. That machine can be Ubuntu machine, that machine can be that supports runners means a server. So when you are defining your CI/CD job using GitHub Actions, also you will say whether it has to run on Ubuntu machine, whether it has to run on Windows machine, whether it has to run on Mac, like that. This is like a agents. In Jenkins, you are saying agent and that labels like that. Similarly, you can say run on this machine, run on this type of machine also you can tell. I mean say GitHub hosted runners. This is GitHub hosted runners means the servers internally created and managed by GitHub, and based on your requirement you can use GitHub runners with this OS, GitHub runners with Windows OS. And again, within this you can have a Java, Python, all commands also it will work like that. Suppose you can use this GitHub hosted runners Ubuntu machines like that for Java, Python, Docker, Terraform, Kubernetes. Suppose you are trying to build and you are trying to have a pipeline for .NET applications, you wanted to run some kind of a PowerShell scripts, maybe you can use you can run your GitHub that job using Windows runners like that. Suppose if you want some applications to be built on Mac OS, you can say run on Mac OS like that also you can do. And also self-hosted runners. Self-hosted runners means you can create your own runner, you can create your own server, and you can also tell GitHub to use your runner, your server also. You can also create your own OS, your own machine as a runner. And self-hosted runners supports any OS also. Any OS you can create some machine. You can also tell the GitHub Actions run the pipeline in this runner. In this machine you can configure whatever additional tools, additional build tools, additional tools also you can configure and run that pipeline here. Self-hosted runners also we'll discuss. So here basically there is something called workflows. Workflows is like your automation file. Here, the way in the Jenkins, you have a Jenkins file. In the GitHub Actions, there is something called workflows. Workflows is nothing but your automation file. So here, that workflow is a single YML file. That workflow is a single YML file that contains logic. That contains logic such as when to run, which jobs to run, how to build, how to test, how to deploy, like that. Suppose if you guys are familiar with the Jenkins, you used Jenkins and Jenkins files like that. Maybe let me show you. Let me show you. I already have some applications right here. Let me take some application. We already implemented CI/CD using Jenkins. So let's say this is Jenkins file. This is like your automation file. In this you have a stages, steps, all these things. In this you have a stages, steps like that also. So this is your pipeline. In this pipeline, agent any means you wanted to run this pipeline in any agent, that you are only creating agents, and you are configuring tools, build tools, you are creating a secrets, if you remember all these things. And here this is like a stage, in this is like a job. In this you have a various stages, each stage has a various steps, like taking the latest code, compiling the code, right, running the unit test cases, checking the code quality. But here, without configuring this tool, you can't execute this in your pipeline. Without creating a servers and agents, you can't run these jobs like that. But here similarly you can implement these type of things also in GitHub Actions using workflow. That workflow is nothing but automation file. So where you can maintain that workflow within the same SCM repository, where you have a source code, within that SCM repository you can go and create one subdirectory called .github. This is like a one .github folder. Inside that workflows folder, there you can maintain a file. That file name can be anything. In that file only you will have an automation, but that pipeline will be defined in YML. That workflow is a YML that contains automation logic. So that like when that pipeline has to be executed, and what jobs has to be executed, and what steps has to be executed, and as part of that step what you have to do, whether you wanted to build, you wanted to test, you wanted to deploy, all those things also you can run. So workflow will be triggered based on various events again. That workflow is like a pipeline. In the Jenkins, you have a pipeline. That pipeline will be triggered based on the build triggers. We have a poll SCM, we have a webhook, we have a poll SCM webhook build periodically. Similarly, you created one automation workflow pipeline, but when that GitHub will execute this pipeline, when it will execute this job or a pipeline, so a workflow can run whenever you are pushing that any changes to that code. Maybe if you are creating a pull request, maybe when you are creating a tag, when you are creating a branch, when you are merging a branch. Otherwise you can schedule cron jobs like that also, you can schedule, or manually also you can run that pipeline like that. That workflow will be triggered when an event, that event can be a push to that Git repository, maybe pull request, maybe tag creation, like that. Suppose in that you are going to give when that pipeline has to be executed. I will write some pipeline also, don't worry. Maybe let me show you. I already have some sample pipelines also created for GitHub Actions also. I have used GitHub Actions also for some sample applications. Maybe here, if you see already this SCM repository where I have a source code, I have this GitHub workflows. Inside that, I have a pipeline like this YML. So this is like your Jenkins job only. So here, like when this is on push means this jobs, here you are defining a jobs. In each job you have a steps like that. So when this job has to be executed, whenever there is a push, whenever there is a push to this main branch like that, so you can have a lot of events. When this pipeline or a job or a workflow, in GitHub we call it as a workflow. When this workflow has to be executed, that workflow is for automation, right? When this workflow, this each workflow will have a multiple jobs, and when these jobs has to be executed, on push means whenever there is a push, again I can say on which branch, if there is a push also I can do. Suppose in the main branch we are pushing something, then these jobs will be executed. So this is like a your name, your workflow name, like a job name. In the Jenkins, you are creating a pipeline, that pipeline name, right? Similarly, this is like a workflow name. This workflow will be executed on push, and this workflow has a jobs. This is one job, and here each job can have a multiple steps. Multiple steps. This is one step. Check out the code, again build a Docker image and push the Docker image. This is like your stages or steps in the pipeline. So this you are not creating a server where the clone will happen, where the compilation will happen, where the build will happen. All these commands will be executed where it is going to be executed on a runners, on a runners, GitHub runners. That GitHub runners is nothing but a servers. That GitHub runners is nothing but a servers that GitHub itself will maintain. You no need to have a separate CI/CD servers. GitHub Actions is like a CI/CD platform integrated within GitHub only. So you just create a workflows like this, then rest GitHub itself will take care. Here we will discuss about all these things. What do you mean by on push? What do you mean by jobs? Here you can see runs on Ubuntu. This means this is like a runner, one server. That server also GitHub will internally create, and it will create one server using Ubuntu OS, and in that servers all these steps will be executed. Steps are stages in your Jenkins, right? Like checking out the code, like executing this Docker commands on that runner, it will execute, it will push like that. Later, if required, you can send notifications also, like the way we have used Gmail notifications, Slack notifications also, you can do this, right? So here, this is like a plugins. This uses, we are saying use this in order to perform this task. You use this like that. We are telling these are like a plugins. The way we have a in Jenkins we have a plugins. Here we have something called actions. So here we are telling for checking out the code. For checking out the code, you need some Git plugin like that. We are saying this actions. So we'll discuss about all these things. What is you? What do you mean by users here? What do you mean by runner here? Right? How to pass variables? Right? How to define a jobs? Right? If one job has to be executed before executing another job, we have something called uses. Like I might say, not uses. There is something called depends like that. Also we have. So we'll discuss about how to write a you know pipelines or workflows. Pipeline or a workflow we call it. in using GitHub Actions. But today I am just giving introduction about this GitHub Actions. So without creating a servers, you can run your workflows, your automation, right? So that workflows or pipelines will be executed on these events. And again, there are three main components. There are three main components here. In GitHub Actions, there are three main components: runners, steps, jobs. Runners, steps, jobs. So there are three main components in your GitHub Actions. One is the runner, another one is steps, another one is jobs. Job is nothing but a group of steps, group of tasks that will be executed inside the same runner. Runner means server, like your CI server, CI agent server, or a CI main server, like that. In Jenkins you have a Jenkins server, Jenkins slave. That job will be executed on the server, right? Similarly here, job is nothing but a group of steps that will be executed inside the same runner, right? So here I am just giving overview about high level overview. We will discuss in further session detailedly what is workflow, what is runner, what is steps, what is jobs, and we'll try to build and deploy sample applications into a virtual machines also. Maybe we'll build and deploy sample applications to the Kubernetes cluster also using GitHub Actions. We'll see all those things also. But for now, this is just an introduction. So GitHub Actions has a three more important concepts: runners, steps, jobs. There are three terms of important components. Job is nothing but a group of steps that run inside the same runner. Suppose if you see, this is my workflow file. Suppose if you see, maybe this is my workflow file. This is my workflow file. So here there is something called jobs. This is one job. You can give any name. So this job is nothing but a group of steps. Group of steps. So here everything is defined in a YML. So this is one step. This is one step. This is one step. Like checkouting the code, right? Building a Docker image, pushing a Docker image, or running the unit test cases. These are like a steps. That steps are defined in one job. That all these steps will be executed on this runner. This runner is like a machine that will be created and managed by GitHub only. So here we have three important components. One is the runners, jobs, and steps, like that. So that is what I am trying to explain here. So there are three important components here. One is basically job, another one is steps and runner. Job is nothing but a group of steps that will be runs inside the same runner. So here one workflow contains one or more jobs. So this is jobs. This is one job that the steps in this job should be executed on this machine, like that, on this runner, like that. A workflow can contain one or more jobs. A workflow can contain one or more jobs. Don't worry, guys. I will explain this in further sessions in a detailed way, like step by step, with a very simple, like a hello world pipeline. After that, we'll try to do everything, build and deployments also. We'll see. A workflow can contain one or more jobs. Each job runs parallelly by default, right? And again, you can add dependencies using needs. Needs means, suppose this job has to be executed after executing some other job also. You can say needs, like that. And a job uses one runner. Runner means a machine where that steps will be executed. Here inside the job you have a steps are like a actual commands. Steps are like a actual commands or actions that you are going to execute inside the job. That steps can be running some shell command like this, or checking out the code like this. This is also one step. This is also one step. That step can be running some kind of a commands like this, or that can be performing some custom action. This is we are saying uses like this. This is one plugin. You can think of one plugin or one shared library. This is going to perform some task. This is going to check out the code. So we will discuss about all these things. What is this actions, where I can find these actions or plugins in Git, again, right? We'll discuss about that later. So here in each workflow you can have a multiple jobs. Each job can have a multiple steps, and that job will be executed on some runner. So runner is a machine. Runner is a machine that is going to execute your actions, your GitHub Actions jobs. There are two types of runners: Git hosted runners, self hosted runners. So Git hosted runner is a managed by GitHub. Git hosted runners is like a managed by GitHub, a fresh VM on every run. GitHub only will create a server and run our jobs and steps defined in that jobs on that runner, like that. Self-hosted runner means that is like your own machine. That is like your own machine. That also you can tell the GitHub to use your runner also if required. If required, suppose you can set up a custom environment. Maybe GitHub hosted runners may have a limited control. You have a limited control on the GitHub hosted runners. Maybe you wanted to have some build tools that is not there in GitHub hosted runner. You can also create your own server and you can tell GitHub to use your server to run the jobs also. That is self-hosted runner. We will discuss about that. So here there are three categories. There are three categories of runners. There are three categories of runners. GitHub Actions provides three main categories. GitHub hosted runners. GitHub hosted runners means fully managed by GitHub. Auto scaling also they will take care, and a clean environment. But that GitHub hosted runners comes pre-installed. Whenever you are using that GitHub hosted runners also, that runners are like a machines that will have a Java software installed, Node Java installed, Python installed, Docker installed, Git installed, Terraform installed, kubectl installed, like that. Maybe you can use Docker commands also in your Jenkins job that will be executed on that Git runner, sorry, GitHub Actions pipeline. Java commands, you can use Docker commands, you can use AWS CLI commands, you can use like that also. They will pre-installed all these things. So this is the best. This hosted runners, GitHub hosted runners is best for general CI/CD, Docker builds, cloud deployments, like that. You can just tell runs on like this, so that internally GitHub will create a one VM with Ubuntu OS. In this VM, all these tools will be installed by default, and your Jenkins, sorry, your GitHub pipeline, your GitHub job have a steps. Maybe you have a step with the maven command, you have a step with the Docker command that will be executed in this runner in this machine. Once your pipeline is executed, it will delete that machine. GitHub will delete that machine, like that. That is hosted runners. Similarly here, self-hosted runners. Self-hosted runners means custom runners. Your own machine, your own machine acting as a runner for your GitHub Actions job. So maybe that can be on-prem server. Maybe you have your own server. That server also you can tell to GitHub. You can tell GitHub execute that job in my own runner, where I have lot of customization I have done, like that. Your own machine acting as a runner, that is self-hosted. That can be your own on-prem server, or that can be your personal laptop, or that can be a server created in cloud like AWS or Azure or GCP, or maybe that self-hosted runner can be a container also. The GitHub Actions can run your job and the steps of that job in a Docker container also, or a Kubernetes pod also, like that also you can configure. This is like your own agent. The way you have created an agent and joined agent to the Jenkins, right? This is like your own agent, own runner that you can use in GitHub Actions also. Why you need to have a custom runners? Suppose you need it for private networks and you need large CPU and memory, and for a lot of large Docker builds, maybe you need to install custom tools, and you may need to do some kind of a cost saving. Suppose if you are using self-hosted runners, suppose if you are using self-hosted runners, that is your own server, GitHub Actions will execute the jobs in your own server, right? That time the charges also little less, because you are not using GitHub hosted runner. It is like your own runner, self-hosted runner also. Like you can do like this also, we'll discuss. Again, there is something called labels. Same, like a self-hosted runner labels. This is very similar to your Jenkins slaves having a labels, and you are saying agent on which agent, like that. We will discuss about all these things. So at high level, workflow is nothing but your pipeline, automation pipeline, that is defined in a YML format. In that workflow, you will have a trigger means when that workflow has to be executed, whether on push, on PR, whether manually or cron schedule, it will execute, like that trigger. And in that workflow, you have a job, like a build a job, deploy job, like that. And in each job, you have a steps, and each job will be executed in a particular runner. This is like one high level example. Here I am just giving example like this. This is my name of the workflow. This is like your Jenkins job name. And when this workflow has to be executed, whenever there is a push on the main branch, we will discuss about various options also there. And this jobs has to be executed when there is a push in the main branch. This is your workflow name, like a job name, that pipeline name, like that. In that pipe workflow, you have a jobs. This is one job. This job, inside jobs, this is a one job. Inside this job, various steps are there. This is step 1, step 2. Like in your Jenkins, you have a stages, right? Stages. Now all these steps of the job will be executed in this runner. This can be checking out the code, it can be compiling the code, creating an application package, creating a Docker image, pushing the Docker image also, like that. This is just an introduction, right? So from here I will continue in the next session. So in the next sessions, we'll try to understand about various things also. There are so much content we need to discuss, right? Various content we need to discuss, like first workflow. We will try to build and deploy. We'll try to build and deploy how to use variables in GitHub Actions, and how to build and deploy, how to use conditions in GitHub Actions, like that. There are so many things we need to discuss. And also here we are going to have a pipeline integrated, like this, where you are going to check out the code. Finally we'll create an actual pipeline after understanding all these things, right? We'll try to create a pipeline where you are going to check out the code. Again, you are going to compile the code, right? Then you are going to like check the code quality, code coverage also if required, using sonar cube, like that. Later you can create a Docker image, you can build a Docker image, you can push the Docker image. And later you can deploy that to EKS cluster or a self-managed cluster also, by executing all these commands, like that also will do, right? But if I directly explain everything, right, you don't understand. So we are going to learn step by step. First of all, what is GitHub Actions? Why GitHub Actions came into the picture? What are the advantages of using GitHub Actions compared to the traditional CI/CD? But what are the limitations of GitHub Actions, right? In which scenario you can go GitHub Actions also? And maybe if you are using GitHub Actions, you need to understand what is workflow, how to create a workflow, when that workflow will be triggered, right? What is workflow, what is jobs, what is runners, self-hosted runners, how to use variables, conditions, all those things also. So step by step we'll learn. So in the next session we will just try to create a sample, very simple GitHub workflow. And first we'll try to understand we'll try to understand workflow, like that YML syntax, workflow, job. In each job you can have a multiple steps, like that. Workflow has a jobs has a steps will run on the runners, like that. So here very simple, like this, like very simple, like hello world, right? Very simple workflow we will create. Later we'll try to complicate things one after the other. We'll try to understand all these things slowly. It takes some time, but I'm trying to explain this GitHub Actions also, right? It is not a mandatory, but some companies may use Jenkins as a CI/CD. Some companies may use GitHub Actions. Maybe some companies may use Azure DevOps. But Azure DevOps also same as a GitHub Actions, because Azure DevOps also managed by Azure as a company, Microsoft company. GitHub also owned by Microsoft. Nowadays, most of the people are migrating from Azure DevOps to GitHub Actions, because again, same thing you can do using GitHub Actions. Azure DevOps came before Microsoft acquired GitHub. Actually, Azure DevOps came into the picture before Microsoft acquired GitHub. So later, Microsoft acquired GitHub. So whatever Azure DevOps can do, same GitHub Actions also doing. That's why nowadays people who are working, or people who are using Azure DevOps also, they are migrating the CI/CD to the GitHub Actions. If you know GitHub Actions, you can easily learn Azure DevOps also. Same thing only, YMLs only, pipeline, same concepts only, but platform is different. Here you are using GitHub platform to create a CI/CD pipelines in GitHub Action. But if you are using Azure DevOps, the platform is Azure DevOps, but the same YML, same syntax like that. But here and there some differences will be there. But nowadays most of the people are migrating from GitHub, that Azure DevOps to the GitHub Actions also, because both are similar and both are owned and managed by Microsoft only. And again, if you know Jenkins, even though you don't know GitHub Actions also, you know CI/CD concept. What is CI/CD? What is the build and deployments? Suppose even though you don't know GitHub Actions also, no problem. If you know Jenkins, learning GitHub Actions also becomes easy. You can go to official website of GitHub and you can see what is GitHub Actions and you can understand. But anyhow, I am trying to explain GitHub Actions also, so that at least you will familiar with the GitHub Actions and Jenkins, two CI/CD platforms also, like that, so that maybe if someone is looking for GitHub Actions, maybe they will, it will help you like this. So from here I'll continue in the next session, guys. Hope you got an idea about what exactly this GitHub Actions, right, how different it is from Jenkins, right? But I have not implemented any pipe a workflow or a pipeline using GitHub Actions. That I will continue in the next session, right? Thank you. That's it for today. See you in the next session, guys.